Close your eyes for a second. Think about the last time you sat near a fire. Maybe a campfire. Maybe a fireplace on a cold night. That warm feeling on your face. The way the flames dance. The way it made you feel safe, peaceful, human. Billions of people for thousands and thousands of years have sat around a fire exactly like that. Our ancestors. Their ancestors. Everyone. Fire is the oldest relationship humanity has ever had. But here's the thing. Not a single one of them ever truly understood what fire actually is. Not until Richard Feynman looked at a simple flame and said something that will completely shatter everything you think you know. What fire really is will change your life, I promise you. Okay, so, fire. You've seen it your whole life. You've used it your whole life. Cooked food with it. Stayed warm because of it. Watched it dance 1,000 times. So tell me, what is it? Go on. Think about it. What is fire, really? Most people say, it's hot. Yeah, okay, but that's not what it is. That's what it does. Some people say it's a chemical reaction. Sure, that's technically correct. But that's like saying a sunset is light bouncing off molecules. Technically true. Completely misses the point. Because here's what's wild. Fire is not a thing. It is not a solid, a liquid, or a gas. It's not matter at all. Fire is an event. It's something happening. Like an explosion in slow motion, a battle between atoms fighting to be together. And the light and heat you see? That's just the universe showing you that atoms are winning. Most people never think about this. They just see fire and think, okay, wood burns, keeps me warm, moves on. Done. But one day, Richard Feynman sat in front of a camera and someone asked him this exact question. What is fire? And Feynman, the greatest explainer in the history of physics, he smiled. And he said something that nobody expected. He said, fire is the sun. And when you understand what he meant by that, nothing will ever look the same again. All right, let's go deep, really deep, down to where fire actually lives, the atomic level. Picture this. You've got a piece of wood sitting in your fireplace, just sitting there, doing nothing, room temperature, perfectly still. It's been sitting there for hours, and right around that piece of wood, there's oxygen. Millions and millions of oxygen atoms floating in the air, bumping into the wood every single second. Every single second. Oxygen is literally crashing into that wood constantly, all day, all night, every moment of your life. So why isn't the wood on fire right now? Why doesn't everything just burst into flames the second oxygen touches it? This is the question that gets to the heart of what fire really is. And the answer is beautiful. See, atoms are not simple little balls. They have something like an energy hill. Feynman used to imagine it like this. Picture a valley. A deep, beautiful valley. And on either side of that valley, there's a hill. Now, oxygen wants to get into that valley. It wants to be close to carbon. The atoms actually like each other. They attract. Carbon and oxygen were basically made for each other. But to get there, to fall into that valley, the oxygen atom has to climb over the hill first. It needs enough energy, enough speed, enough momentum to get over the top. And at room temperature, the oxygen atoms are just wandering around lazily, bumping into the wood, but not hard enough. They touch the surface and just bounce off. Nothing happens. It's like trying to throw a ball over a wall that's too high. You can keep throwing and keep throwing, but if you don't throw hard enough, it's never going over. So the wood just sits there, patient, waiting. But the second you give those oxygen atoms enough energy to get over that hill, everything changes. And that's exactly what a match does, or a spark, or lightning. It gives just enough energy to a few atoms to climb over that hill. And once even one atom makes it over, falls into that valley, it releases a massive amount of energy on the way down. And that energy hits other oxygen atoms nearby, pushes them, gives them the speed they need to climb over their hill. And those atoms release energy too, which hits more atoms, which hits more atoms, which hits more atoms. One after another, after another, after another. Feynman called this a terrible catastrophe. And he was right. Because in less than a second, millions of atoms are all falling into that valley at the same time, each one releasing energy, each one pushing the next. That chain reaction of atoms crashing, snapping, jiggling, releasing energy over and over and over. That is fire, not a thing, a chain reaction. An avalanche of atoms finally getting what they wanted, and it doesn't stop, because the energy it creates keeps pushing more atoms over the hill. The fire feeds itself. It becomes self-sustaining, as long as there's wood. And as long as there's oxygen, the catastrophe continues. Okay, so now we know what fire is. A chain reaction of atoms snapping together and releasing energy. But here's the next question. Why do we see it? Why does it glow? Why does it give off light? Because that's kind of weird, right? Atoms are invisible. They're way too small to see. So why does fire show up as this big, bright, dancing thing? Here's what's happening. When those atoms snap together and release energy, some of that energy goes into making the atoms jiggle like crazy. And that jiggling, that wild, chaotic motion, that is heat. So when you feel warmth coming from a fire, you're literally feeling atoms shaking and vibrating and crashing into your skin. Your skin atoms start jiggling too. And that's what your brain reads as warmth. Heat is just atoms being noisy. But what about the light? Okay, so here's where it gets really cool. When atoms get super energized, their electrons, those tiny particles orbiting the nucleus, they get excited. They jump up to higher energy levels, like a kid jumping up steps on a staircase. But they don't stay there. They can't. It's unstable. So they immediately fall back down. And when they fall, they release that energy as a tiny burst of light, a photon. Every single photon of light you see coming from a fire is an electron falling back down a step and releasing its energy. Millions and millions of electrons jumping up and falling down every single second, each one releasing a tiny photon of light. And all those photons together, that's the flame you see. Now, here's something really interesting. The color of the fire tells you about the temperature. The bottom of a flame near the base is the hottest part. The electrons there are jumping to even higher levels. And when they fall, they release higher energy photons, higher energy light. That's blue and white. The cooler parts of the flame near the edges release lower energy photons. Orange, yellow, red. So when you look at a campfire and see orange and yellow, you're actually seeing a cooler flame. A fire that's burning at maybe 600 degrees Celsius. But if you ever see a blue flame, like on a gas stove, that's way hotter, over 1,000 degrees, the fire is literally painting its own temperature and light. And here's a fact that kind of blows people's minds. A candle flame? It's only about 1,800 degrees Fahrenheit. Sound hot? Sure, but compared to some fires, it's almost lukewarm. The surface of the sun is 10,000 degrees Fahrenheit. And we're going to talk about that, because it connects to something Feynman said that will change everything. But first, why does fire go UP? Think about it. Every fire you've ever seen, the flames always go upward, always reaching for the sky. Why? It's not magic. It's not some mystical force pulling fire toward the heavens. It's actually one of the simplest things in physics. Hot air rises. That's it. That's the whole secret. See, when fire heats the air around it, that air gets less dense. It becomes lighter than the cool air around it, and lighter air floats up, just like a bubble rises in water. So the hot gases from the fire float upward. And as they rise, they pull in fresh, cool air from below. And that fresh air brings more oxygen. More oxygen means more fuel for the fire, which creates more heat, which makes more air rise, which pulls in more oxygen. It's a cycle, a beautiful, self-sustaining cycle. The fire literally creates its own wind to keep itself alive, and that's why flames are teardrop-shaped. The hot gas rises at the top, stretching it into a point. Cool air rushes in at the base, keeping it wide. The flame is constantly moving, dancing, flickering, because the air currents are constantly shifting. Little turbulences, little changes in flow. The flame is responding to every tiny movement in the air around it. That's why fire feels alive, because in a way, it is. It's self-sustaining. It feeds itself. It creates its own environment. It responds to changes around it. Some people throughout history actually thought fire was alive. The ancient Greeks thought it was one of the four elements, a living force of nature. And honestly, watching a fire dance on a cold night, knowing what we know now, they weren't entirely wrong to feel that way. But here's the thing. All of this, the dancing, the flickering, the rising, it only works because of one thing, gravity. Because without gravity, fire does something absolutely insane. NASA actually set fire to things in space, on purpose, on the International Space Station. And what happened blew every scientist's mind. Remember how we said flames go up because hot air rises? Well, in space, their IS no up. There's no gravity pulling anything down, so hot air doesn't rise. It just expands outward in all directions equally. That means the flame doesn't stretch. It doesn't dance. It doesn't flicker. It becomes a perfect sphere, a tiny, calm, glowing ball of light, just floating there. Silent. Still. Almost hypnotic. Astronauts who watched these experiments said the flames looked completely alien. Nothing like anything you've ever seen on Earth. And it gets even weirder. Remember how we said fire creates its own wind to pull in oxygen? That whole cycle of hot air rising and fresh air rushing in. In microgravity, that cycle doesn't exist. There's no convection, no wind, nothing. So how does the fire get oxygen? It doesn't get pulled in. The oxygen molecules have to accidentally drift into the flame on their own, by pure random chance, one molecule at a time. Scientists call this molecular diffusion, and it's incredibly slow compared to what happens on Earth, which means fire in space burns slower, cooler, and for way longer. A flame that would burn out in seconds on Earth can keep going for minutes in space because it's barely getting any oxygen. And the color. Remember how orange flames mean cooler and blue means hotter? Well, space flames are mostly blue, because without all that soot and particles being pushed around by convection, the fire burns cleaner, cooler, and calmer. But here's where it gets really crazy. NASA scientists discovered something during these experiments that they literally did not expect. They called it a cool flame. After a fire in space goes out, sometimes it comes back, all by itself, with no visible light, no heat you could feel. An invisible flame, burning at temperatures so low it's impossible on Earth. Scientists still don't fully understand why this happens. Fire in space is still teaching us things we didn't know, even after thousands of years of watching flames on Earth. But now, we need to talk about the biggest, most powerful fire in our solar system, the sun. And here's where Feynman's revelation hits you like a freight train. Okay, everyone thinks the sun is on fire. Billions of people look up at the sky and think, there's a giant ball of fire burning up there keeping us warm. It's one of the most common beliefs in human history. And it is completely, utterly, 100% wrong. The sun is not burning. It is not on fire, not even close. Fire needs oxygen. You know that, right? We just spent 17 minutes talking about how fire is a chain reaction between carbon and oxygen. Well, there's no oxygen in space. None. Zero. A vacuum. So how is the sun doing what it's doing? The answer is something called nuclear fusion. And it is nothing like fire. It's a completely different process. A different kind of energy entirely. See, fire is a chemical reaction. Atoms rearranging themselves. Electrons jumping between molecules. It releases energy, sure, but not that much. Nuclear fusion is nuclear. It happens inside the nucleus of atoms, not between them. Inside them. In the core of the sun, the pressure and temperature are so extreme, so unimaginably intense, that hydrogen atoms are literally being crushed together. Smashed so hard that they fuse, they merge into helium. And when that happens, a tiny bit of mass disappears. It converts directly into pure energy. Remember Einstein? E equals mc squared. That's exactly what's happening. Mass becoming energy. Pure, raw, incredible energy. And the amount of energy released, it's about 1,000,000 times more powerful than any chemical reaction. 1,000,000 times more than fire. The sun isn't a campfire. It's a nuclear reactor. The biggest one in our solar system. And here's what makes this beautiful. The sun has been doing this for 4.6 billion years. And it has enough hydrogen fuel to keep going for another 5 billion years. If the sun were actually burning like a fire, like actually using combustion, it would have burned out in a few thousand years. It wouldn't have lasted long enough for life to evolve on Earth, everything we are, everything that exists on this planet. It only exists because the sun is not a fire. If it were a fire, we wouldn't be here having this conversation. But here's the thing, and this is where Feynman's mind-destroying insight comes in. Even though the sun isn't technically fire, there's a connection between the sun and every fire you've ever seen that is so deep, so fundamental, it changes everything. Richard Feynman was sitting in his living room, being filmed for a BBC series called Fun to Imagine. Someone asked him about fire, about what it really is. And Feynman leaned forward and he said something so simple, so quiet, so profound, that it stopped people in their tracks. He said, fire is stored sunshine. Let that sink in for a second. Fire is stored sunshine. Here's what he meant, and pay attention, because this is the part that rewires your brain. Remember how we talked about trees? Where does a tree come from? Most people think the ground, right? You plant a seed in the ground, water it, and it grows. Wrong. A tree comes from the air. Carbon dioxide in the atmosphere gets pulled into the tree through its leaves. The tree uses sunlight, actual sunlight from the sun, to rip apart that carbon dioxide. It separates the carbon from the oxygen. The oxygen gets released back into the air. That's why we breathe. We owe our lives to trees doing this. But the carbon? The tree keeps it. It uses it to build itself. The wood, the trunk, the branches, all of it is carbon that the tree pulled from the sky using the power of sunlight. So every piece of wood is actually a record, a storage unit. It's holding on to the energy from sunlight that was captured years ago, maybe decades ago, maybe centuries ago. The tree was basically a battery, charged by the sun. Now, you take that wood, you put it in a fireplace, you light it, and what happens? All that carbon that the tree spent years pulling apart from oxygen, it goes back together again. Carbon and oxygen reunite into carbon dioxide. And all that stored energy, all that sunshine that was locked inside the wood, it comes out as heat, as light, as the warm glow of a fire on a cold night. Feynman said it perfectly. The light and heat coming out of that fire. That's the light and heat of the sun that went in. When you sit in front of a campfire and feel warmth on your face, you are literally feeling sunlight. Sunlight that hit a tree maybe 10, 20, 50 years ago. Sunlight that got captured and stored and locked inside the wood. And now it's being released, coming back out, returning to where it came from. Fire is not destroying the wood. It's undoing what the tree did, returning the sun's energy back to the universe. It's a cycle. The sun puts energy in. The tree captures it. The fire releases it. Over and over and over, for millions of years. And that is what fire really is, not just a chemical reaction, not just atoms snapping together. It's the sun's energy coming home. So here's where we are. Fire is not a thing. It's an event. A chain reaction of atoms finally getting close enough to do what they always wanted to do. Crash together. Snap together. Release the energy that was keeping them apart. The light you see, electrons jumping and falling, painting the temperature of the flame in color. The flickering, fire creating its own wind to feed itself oxygen. A self-sustaining cycle powered by gravity in space. Fire becomes something completely alien, a calm blue spherical ball of light, silent, still, almost alive. The sun isn't even fire at all. It's nuclear fusion, 1,000,000 times more powerful, and it's the reason we exist. But the most beautiful part, every single fire you've ever seen, every campfire, every candle, every fireplace on a cold winter night, was the sun's energy being released back into the world. Feynman saw this. He saw the connection that nobody else saw. That fire and sunshine are the same thing, just separated by time and stored inside a tree. Next time you sit near a fire, really look at it. Watch the flames dance. Feel the warmth on your skin. And remember, that warmth, that light, it traveled 93 million miles from the sun. It got captured by a tree. It sat inside the wood for years, waiting. And now it's here, with you, in this moment. Fire isn't just heat and light. It's a message from the sun, delivered across time. And Feynman, the greatest explainer who ever lived, saw that when nobody else did. That's what makes science beautiful. Not the equations, not the formulas, but the moments when someone looks at something everyone has seen 1,000 times and sees something nobody ever noticed before. Fire has been with humanity since the very beginning, but we're only just now beginning to truly understand what it's been telling us all along. If this hit you the way it hit me, smash that like button. Subscribe. Turn on notifications, because the universe has 1,000,000 more secrets like this one, and we're going to uncover every single one of them. I'll see you in the next video.